Okay, I will go through the electronics questions of your worksheet, right, in this video. Right, the first question, right, they say figure 7 shows incomplete. Right, why is it incomplete? They did not give you all the components. I fill in. Basically, this is the answer. Right, I fill in the answer. Right, let's take a look question first. Right, name the components labeled A, B, C, D. A, B, C, D. A is given. Let me see. Component A was given. B also given. C also given. Right? Is this one, this thing, and this thing that is not given, I think. Right? They ask you to name component A, B, and C. Right? So A, very clear, is the thermistor. Right? Thermistor. Please know the symbol. Right? It's a resistor. Right? With one line that is parallel. Right? Parallel to the rectangle, and then a nice slanting up. All right, the other sensor that you must know is, of course, your LDR, right? Light dependent resistor, right? LDR. The other one that you should know is moisture sensor, right? Just draw 2 metal bar, right? Moisture sensor. Okay, then they ask you B, of course, B is a resistor, right? B is a resistor. Right, C is a transistor. Right, it's a transistor. You must know that C is a transistor, and the function is to act as an automatic switch. All right. Let's move on. Draw the circuit symbol of the fan output. Now they say this is a fan. This is a fan. They want you to draw the symbol. Is there an electronic symbol for fan? There is no electronic symbol for the fan. Basically, you can draw a motor, right? We all know that you use a motor to turn the fan blade. All right. Now, explain the purpose of component B. This is component B. Remember, component B. I told you many times when you see a resistor and they ask you why do you need a resistor. All right. The word protect should come to your mind, right? Resistor usually used for protection, especially in the circuits that you know. All right, except for voltage divider, right, which is to transform a bigger voltage into a smaller one. Otherwise, when you see a resistor, it must be put to protect a component. Now, in this case, this resistor is to protect the transistor, right? Protect the transistor. Okay, so I write down here, protect the transistor by limiting the base current. Right, by limiting the base current. I will send you this answer sheet, right? So don't have to worry too much. Explain the purpose of component C in the circuit. Component C in the circuit. Told you component C is a transistor, right? It's a transistor. Of course, you already know that the purpose of the component, right? The purpose of component C is to act as an automatic switch. Alright. Then they ask you to redraw the circuit symbol for C and label the 3 connections. Label the 3 connections. Basically, there are 3 terminals down here. Right? Transistor, you have a base. The one with the arrow is the emitter. Right? Then the other one is the collector. Okay? How to draw? Right? How to draw a vertical line. Right? Draw the base, which is a horizontal line. Then you draw 2 lines slanting. Then you draw the arrow from the emitter. Draw the vertical line again. Right? Draw the vertical line for the collector. Right? So this is the base, this is the collector, and this is the emitter. Okay. Explain how component A works in the circuit. Now this is the component A. Now of course it is to sense the purpose is of course to sense the temperature. It acts as a sensor to sense the temperature. All right, thermistor. Um, let's see. Let's see where is the answer. Okay, the resistance of component A changes with the temperature. All right, it has high resistance when temperature is low. All right, when the temperature is low, no current flows into the base of the transistor. Now let's take a look at the diagram. This says this component, the resistance of this component, the thermistor, varies according to the temperature. When the temperature is low, the resistance is high. Now, from here we know you can assume that this is a NTC lah. They did not give you NTC. They did not show you that this is a NTC, negative temperature coefficient. Now it goes in the opposite. When temperature is high, resistance will be low, right? For NTC, right? For NTC thermistor, all right. For PTC, I just write down for NTC, this is resistance, this is temperature, right? For this is PTC, right? Now when the temperatures go up, resistance goes down. For positive temperature coefficient, temperature go up, resistance must go up. All right. Okay, next. Okay, let me see. What happens when the temperature goes up? For NTC, resistance comes down, right? Resistance comes down, current will be able to flow through here, and the bulk of it will go into the base, right? Base of the transistor. Turn on the transistor, right? Turn on the transistor. Once this thing turned on, current can flow through, right? Current will be able to flow through the motor, through the collector to the emitter. Now, when the temperature is low, resistance is high. Correct or not? Temperature is low, resistance of this is high. High resistance, so little current can flow through. With little current flowing through here, no current goes into the base. Alright, you can see there is no current. There's no base current. No base current, transistor is off. When transistor is off, current cannot flow. Right? Current cannot flow through. Right? So the output component has got no current down here. Alright, the second part is written down here. When temperature is high, right? When temperature is high, resistance of component A is low. Current flows into the base of the transistor. Right? Resistance low, current able to flow into the base of transistor, and transistor turn on. Transistor turn on, allowing current to flow to the fan. Right? Flow through the fan. Okay, next. Name and draw the circuit, symbol or component that can allow a low voltage circuit to control a high voltage circuit. This one, when you say, must be a relay, right? It is a relay. This is a symbol of relay. Sometimes you will see people drawing the symbol of relay in this manner. All right, this draw. Okay, so relay usually have two sides, right? The side with the coil, this is a coil, right? Electromagnet basically. So when current passes through this coil, this is a primary circuit, this is the secondary circuit, right? Primary, this is second. This is the low voltage side, this is a high voltage side. All right, so when current passes through here, the electromagnet, this thing becomes an electromagnet, it will attract this to come in, right? This thing to come in here. When it's comes in here, it will complete the circuit. It completes the circuit. So this is a high voltage, right? High voltage circuit allows current to flow through, right? Now explain how the circuit shown in figure 7 can be built and tested quickly and in an easy manner. Now the circuit can be constructed and tested quickly on a breadboard using a 9-volt battery as a source. Now you see, they say this thing is a 9-volt, right? 9 volts, you can get a 9-volt battery, the squarish one. All right, all the other connection, how do you connect them? Right, you connect them on the breadboard. Now do not know what is a breadboard, right? If you do not know what is a breadboard, it is actually in your revision guide. Turn to the chapter to the chapter that tells you a lot about electronics, right? Then you'll find out what's a breadboard. All right. Okay. Move on. I'll move on to the next question. Question number 4 for electronics. Now, electrical and electronic equipment uses different types of output components. Copy and complete, right? Okay, they ask you complete. It's simple. Now, this component give you motion, right? It give you motion. The motor. So the use, you can produce rotary motion when current passes through it, right? When current passes through it, it produces motion. What type of motion? Rotary motion. So it can be used in, right, toy car, right? Can be used in toy car, electric scooter, right, etc. Now buzzer, right? Buzzer, basically you want to make a sound an alarm, right? So this is the symbol. Now please know the symbol, right? Know the symbol. Otherwise, you will not even be able to understand the question. Right? They show you the symbol. You need to know that this is a buzzer. The next one, they give you this symbol. This symbol is given. This is of course a LED. I hope you can recognize. How do you, if I give you a LED, how do you know which side is a positive, which side is a negative? This is the positive side, this is the negative side. This is the anode, this is the cathode. Alright, now if I give you a LED, right, a brand new LED, now you should know that how to identify, right? Shorter leg, right? The shorter leg is the negative side, or right, the side with flat edge, right, which is also the negative. Right, go and look for the side with the flat edge. Now if you look at the LED, it will be like that, right? The two legs are like that, the two legs are like that. So basically this leg that is closer to the flat side is the negative, right? Negative. Okay, relay, all right, the symbol, right, is used for isolating a low voltage circuit from a high voltage circuit. Now I will say I refer to my deck of slides on relay. All right. Okay, next, this is the diode, right? Diode. Now this is a diode. This is a light emitting diode. Right, they both only allow the current to pass through in one direction only in this direction. That is why you need to connect the polarity correctly. All right, you need to connect the polarity correctly. Otherwise, current cannot pass through. Same thing as the LED, right? One side only. Current can only pass one side. All right, so this is called a diode. Now, where do you use diode? It is used in a rectifier to convert. Right, one use is rectifier. Alright, to convert the AC to DC. Now the other use of course is to protect, right? Component from reverse voltage. Now reverse voltage, okay, basically it is correct, right, for you to put because there's a coil down here, motor has a coil, so you should put a diode in this manner. Otherwise, when you switch off the motor, there will be a high reverse voltage that could spoil, right, that could damage your transistor. Same thing if you put a relay down here. Because relay is a coil, alright, there is a coil. A coil, that means what? Electromagnet. The electromagnet, right? You need electromagnet inside a relay. So you will need this protective diode. All right, refer to my deck of slides on relay, and they will explain a little bit more on that. All right, so now there are two ways that the diode is being used. Okay, then now figure 9 shows an incomplete circuit in which a bulb lights up when darkness is detected. All right, incomplete, they didn't show you, right? This is already completed. Now I added in this thing because this is a light dependent. Now the moment they say in darkness, I know that they want to detect light, right? They want to detect light. They want to light up, so the output component, this must be the output, so I must put a bulb down there, right? They want it to light up. All right, name and draw the circuit. Symbols of the components needed at position A, B, C, and D. Now A, I know that I need to protect the transistor, so I need a base resistor to limit the current, right? To limit the base current, to protect transistor from excessive base current. I do not want the base current to be too huge, right? So I want to limit the base current. Now B, name and draw. So this is a bulb lah. Can or not? This is a bulb. This one is a resistor, right? Resistor. This one, this is a light dependent resistor, LDR. Okay, for the circuit to function. Okay, name. Now how come I put a LDR down here? So when LDR, we know that the resistance of the LDR will be very high when it is dark, right? It is very high. So when it is bright, when the surrounding is bright, right, resistance is very low, so current flows through here. They see a low resistance path down here back to 0 volts, so the current will flow here. All right, current will flow here. It will not flow in the base, so no base current. Transistor is off, light bulb is off. Now you do not need to turn on the light bulb when the surrounding is bright, which is why they arrange it this way. Now when it is dark, resistance is high. Resistance is high, so current flows into the base. Right, current flow into. Why is it so? Now, if you take a look, this is a voltage divider. Right, this is a voltage divider. So when in darkness, this resistance is very high. The voltage at this point will follow the resistance, right? It will become very high as well. The voltage is high, it will push current, right? Push current into the base. Alright, push current into the base of the transistor. Turn on the transistor. Once the transistor turn on, it allows current to flow. This line represents 6 volts. It will allow current to flow through the bulb all the way down. Right? Okay, if you reverse, if you put LDR on top and resistor below, it will not work. Alright, it will only turn on when it is bright. Okay. Then the next question asks you to name and draw the circuit symbol of the component that can adjust the sensitivity of the circuit. Now, of course, the component. Now, please just remember variable resistor. Alright, variable resistor. Now, you will put the variable resistor down here. Instead of putting a resistor that cannot adjust, you cannot adjust the resistance of a resistor, you will put a variable resistor. Now you can implement a variable resistor using a potentiometer. You know this is a potentiometer, right? Potentiometer, there are three terminals, right? There are 3 terminals, 1, 2, 3. Right? What you need to do is you short, right? You link this center leg with one side, and then you just take 2 sides, right? These 2, and then you can use it as a variable resistor, right? Right, they are equivalent, right? These two are now equivalent. You can forget about the third terminal, right? And then you can use this thing as a variable resistor. Okay, from now to your examination, right, if you have any questions that you need me, right, to explain any further, drop me a text and I'll try to address it, right? All the best for your national exams.